In this video, I'm going to be walking through the testing methodology that I use when working within solvers. And I'll spend the first part of this video within slides talking through this at a more conceptual level, and then we'll dive over into PioSolver and GTO Plus to actually look and see how this actually manifests itself through practice. And this methodology is based on the scientific method. As I've introduced in Module 3, it's important to always define your problem. And when you define your problem, you're going to set up tests to be able to solve that problem. And when you do set up those tests to analyze poker scenarios, I recommend that you rely on the scientific method. The scientific method is not anything that I invented it's not even something that's specific to poker. The scientific method is applicable to a large swath of problems throughout all of life. And it boils problems and solving problems down into the 6 steps on the right-hand side of the screen. So typically within the scientific method, when you have something that you're trying to find the solution of, you may start with an observation, and that observation could be something that you see in nature. It could be a potential problem that you want to know the answer to, but it's something that you actually see or a scenario that you wanted to define. And then you move towards actually defining the question, or you ask a question, or specifically defining the problem, as I've referred to in multiple videos. From there, you may develop a hypothesis as to what you think the answer to that problem is before looking at any empirical data. Then you'll develop a test or an experiment to capture data, to study the problem and determine, is your hypothesis valid or is your hypothesis null? From there, you can reach a conclusion one way or another and develop some findings or some results at the end. When you're using this type of approach to investigate various scenarios using solvers, it's important to make sure that you stay focused on the problem that you're trying to solve and ultimately identify different ways in which you can manipulate the data to find an answer. That's the test, that's the experiment that you're ultimately doing to try to reach a conclusion, to try to reach a result. But constantly reminding yourself of the problem that you're trying to solve is an important factor as well too. It's easy to get lost in solver data, and grounding yourself in this scientific method can help you maintain your focus while you're doing so. Now, if you stick with just this approach, this scientific method, it's a great approach to be able to work through any solver problem. But what I've done is I've kind of refined this process over time, and I have a little bit of a derivation of this on the next slide, which I'll walk through, which is poker specific. So the scientific method here applied to solvers. And I've broken this down into 4 steps. And that step starts with specifically defining a problem. It then works towards establishing your baseline. We'll then test our input sensitivity and then finally develop insights. And as you can see here is I've also closed this loop because I believe that any insights that you generate from a solver or any insights that you generate from poker study, oftentimes it's going to lead to further questions. This is a game in which we're constantly still learning new information. So any insights that we generate may lead to additional questions that we want to start diving into even further. So let's go through these in a little bit more detail, starting with specifically defining a problem. And I'm going to sound like a broken record throughout this course. I've mentioned this several times already. I'll continue to mention this throughout the course, but defining a problem right away is the best way to work through solvers. Rather than haphazardly diving into outputs, we want to start with a clear problem that we're trying to solve and defining that as specifically as possible. So that could be things like, how often should I continuation bet this board? Or what is the right sizing for a single bet strategy? The problems don't necessarily matter in detail right there, but it matters that you do have a problem that you're trying to solve. The next step would be to establish your baseline. Your findings are going to have the greatest impact when we can start with a baseline reference point. And that could take place through things like node locking, which we'll cover in the next module, in Module 5, Or it could be done just by anchoring to an equilibrium point and changing some baseline inputs one after another. But by starting from a known foundation, we can interpret our findings better than we can by just haphazardly starting from just some random reference point. And ultimately, that can help us integrate our findings into our overall knowledge base by anchoring our findings to something. The next thing is testing input sensitivity. We can test input sensitivity by introducing additional questions that require us to adjust those inputs. It's generally best to change only one variable at a time to isolate that input's effect on the output. And then we can align our changes to profile adjustments, which can be really, really powerful for improving our strategy execution. So things like asking the question like, how would this differ if our villain significantly underbluffed, can really help us answer the question, well, how would our baseline strategy change if this particular variable is present? And then finally, the last thing is to develop insights. We want to examine the outputs by comparing our variations together. Recording the magnitude of our different input adjustments is important to help us get a sense for how different our various inputs affect those outputs. And then the knowledge that we ultimately gain from all of our different solves can help us refine our initial baselines and develop findings that we can translate into the rest of our overall game. We'll finalize this section by talking through some controlled experiments. As we've demonstrated, we are unlikely to ever find the true equilibrium state of a poker scenario because our inputs just aren't going to be accurate. But the true value that we can derive out of solvers doesn't come from finding that equilibrium. Instead, it comes from understanding concepts about how the solver reaches its solution. And then the best way to actually reach these findings is through these controlled experiments in which we change one input while holding the rest of those inputs constant to measure the impact that our change has on the outputs. By controlling the test in this manner, we're more likely to be able to draw direct connections between our assumptions and their true impact on the expectation value. Now, this process of testing can yield some really important insights and help us better understand how the solver algorithms reach a solution. You hear that all the time when people are talking about solvers. Well, the algorithms, we want to understand how the algorithms are reaching a solution. And the solver algorithms, unfortunately, can't talk to us and explain to us why and how it's doing the things that it's doing. But by testing over and over again and by isolating various inputs while changing other inputs, we can build these controlled experiments that can help us improve our overall understanding of this game. So let's see this testing methodology in action. Let's dive back into the solvers and take a look at how we might actually use this testing methodology to look at various outputs.